Hello everyone, welcome back to our channel. This is Raj from Radical Tech Art, your process automation strategist. Today we are diving into fundamental topic in instrumentation and control, and that is types of signals. We all break down analog, digital, 420 milliampere and Modbus signals in a simple and practical way. So let's get started. First, let's start with analog signal, the backbone of traditional industrial automation. These signals are continuous and vary over time according to their input like temperature and humidity. Analog signals are continuous signals that can have an infinite number of values within a specific range. Let's take one example. If you are measuring temperature from temperature transmitter and your minimum and maximum value is 0 to 100, then its output signal from 4 to 20 milliampere can show continuous signal that can have infinite number of values within 0 to 100 degrees Celsius. Another example you can take is a pressure transmitter providing 4 to 20 milliampere signal. These signals' main advantages are high resolution, suitable for representing nature variations, and disadvantages are susceptible to noise and interference, and also signal loss over long distances. Next, we have digital signals used in modern automation system, mainly give output in either on or off, represented as ones or zeros. This makes them highly reliable and less affected by noise. A simple example is proximity sensor in conveyor system. It detects objects and sends high or low signals to a controller. Digital signals are great for fast and accurate decision making. Second example you can take is push buttons in control panels. These signals' main advantages are they are immune to noise and interference, easy to process and store, and reliable over long distances. And their main disadvantages are less resolution compared to analog signals, limited to binary like on and off representation. Now, third signal is 4 to 20 milliampere signal. The 4 to 20 milliampere current loop is an industry standard signal used to transmit analog data over long distances with the minimal signal loss. It represents a process variable using current instead of voltage. Their main advantages are less affected by electrical noise, and second is maintains accuracy over long distance, and third is can power field instruments, loop power devices. And their main disadvantages are require extra components like resistors and converters for direct digital interfacing, and second is limited to single variable per loop. Now let's go through fourth one, Modbus communication. Modbus communication is serial and TCP/IP protocol available. Modbus is a serial communication protocol used for transmitting data between industrial devices. It also allows multiple sensors, controllers, and PLCs to communicate over a network. Let's take one example. A PLC collecting data from temperature, pressure, and flow sensors over a single Modbus network. Now let's check types of Modbus protocol. Modbus protocol has Modbus RTU, mainly serial communication, and Modbus TCP/IP, it's Ethernet-based communication protocol. Their main advantages are can communicate with multiple devices over a single cable. Second is reduce wiring complexity, and third is allows long distance communication. And their main disadvantages are requires a proper addressing and configuration and can have latency issues in large networks. The selection of the signal depends on factors like accuracy, noise, immunity, distance, and the number of variables to be transmitted. Use analog signals when precision is required but distance is short. Use digital signals for simple on-off control. Use 4 to 20 milliampere signals when transmitting process data over long distances. And you can use Modbus for multi-device communication in industrial networks. So this was all about 4 major types of signals used in instrumentation and control field. Hope you all like this video. Thank you so much for watching. See you all in my next video.